Students, a question which is based on the dipole. We will go through it. An electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 raised to the power 6 Newton per coulomb. It experiences torque of 2 Newton meter. The charge on the dipole of the length 2 centimeter will be given by the options are there. Now if you see the dipole, when you place the dipole in an electric field, it will experience a torque. So a dipole which is placed like this at an angle of theta, so it will be experiencing a force in this direction because positive charge is there and electric field is having that same direction, and another charge which is minus q which will experience a force in this direction. So both the forces which is acting on the dipole means couple of forces are acting, and when couple of forces are acting, they will create a torque. Now once torque is there, means torque is equal to perpendicular force into perpendicular distance. Now perpendicular distance that can be calculated with the help of this. This is the perpendicular distance. So once we have got the perpendicular distance and force, we will have a torque which will be given by force into perpendicular distance. Now torque finally we will have in terms of P E sin theta, where P is the dipole moment and E electric field and the angle theta between them, between electric field and dipole. So finally we have got this P sin theta. Once we have P sin theta which is equal to torque, we can determine the value, desired value here, the charge on the dipole which we have to calculate. So length of the dipole that we have got 2 centimeter, we have converted it into meter. P is equal to 2aq. Now 2a is given in terms of length L, this length into q. So we have taken it in terms of q is equal to p upon n. Now p torque will be given by this relation. Now here this will be, we can write it like this because it is in the form of magnitude and it is a vector torque. Now torque is equal to P E sin theta. So we can substitute all the values. 2 Newton meter P, 2 into 10 raised to the power 6 Newton per coulomb is given to us sin 30, that is 1 by 2. So it is, if we calculate 2 by 2, so it is 2 into 10 raised to the power minus 6. That is the dipole moment which we are getting. Once we have got the dipole moment, we can substitute in it. We have got this 2 into 10 raised to the power minus 6. And the length which is 2 centimeter means 2 into 10 raised to the power minus 2, 2 to 2 cancel, and this is 2 10 raised to the power minus 20, it is minus 6, so minus 6 plus 2, that will give the q is equal to 10 raised to the power minus 4 coulomb. So ultimately we have the option 10 raised to the power minus 4 coulomb. B is the correct answer. So for the numericals which is based on the dipole, it will be on directly on the torque also, on the energy also, the work done by the dipole. So in the next we will see how we have to calculate the work done